To actually draw one of these Venn diagrams that notes the cardinality of the regions, I actually need a lot of information. So let's draw a Venn diagram here that gives me those cardinalities if I know all of this stuff. So the cardinality of the universal set is 28, the cardinality of A is 17, and so on. Okay, I know all of these pieces of information. I want to draw a Venn diagram. Apparently, I want my rectangle for my Venn diagram to be red. Fine. I'll draw the circles to be red as well. And we'll switch to a different color. And also, we'll make ovals instead of circles. Okay. A, B, C, the universal set. Now, when I'm filling in a Venn diagram like this, I always want to start in the middle. Okay, I always want to start right here, because that'll be the easiest place to start. And in fact, I'm given, and need to be given, or need to be able to figure out that piece of information. The cardinality of their intersection is 3. There are 3 elements common to A, B, and C. Great. Now I'm going to work my way out just as if I were filling in this Venn diagram. I know that B intersected with C is 4. I've already accounted for one of those, or 3 of those. So I need a 1 here, right? 4, I've already got 3 of them. That gives me 1. That should be there so that B intersects C is 4. So look at our next one. A intersects C is 11. Well, I already have 3 of those taken care of, so I need an 8 right here. A intersects C is 11. That means I need an 8 to go with that 3. A intersect B is 6. 6 minus 3 gives me 3. So I need a 3 right here. Now A intersect B is 6. Okay, still working backward from the way this was given to me. C has 13 elements in it total. I already have 8 and 3 and 1. That's 12. I have 12 of C's 13 elements. That means there's 1 more to be had, right? For the cardinality of C to be 13, and I already have 8, 9, 10, 11, 12, I need 1 more. So that C, just in C, should be 1. B's cardinality is 9. In B, I've already got a 3, and a 1, which is 6, 7. So I need 3 more. This should be a 3. A's cardinality is 17. Well, in A, I already have 3, 3, and 8, which is 14. 17 minus 14 is 3. So A should have 3 in it. Finally, I'm given that the universal set has 28 elements in it. I now need to count how many do I have so far. 3, 6, 9, 10, 13, 14, 22. I have 22 of the 28 elements. 28 minus 22 is 6. There should be a 6 out here. There are 6 elements in the universal set, not inside of A, B, or C. All right, I want to do another example of that. And this is one of those bad ones where you're going to say, oh, you told us there weren't any tricks in math, but this one seems like a trick. What it really is supposed to do is to make sure that you're paying attention when someone tells you something. So I've got all this data, all these numbers, right? It's really easy to get just blinded by them and say, well, yeah, that'll work out. I guess A intersect B intersect C is 6 or whatever. But we need to be a little careful because as we're about to find out, this data is junk. So let's start in the middle. I have 6 elements that are in the very middle. Great. Moving outward, B intersects C is 8. B intersects C already has 6, so I need 2 more. A intersects C is 7. I already have 6, so I need 1 more. A intersect B is 14. I already have 6, so I need 8 more. Okay, moving again, bigger. C is 15, so I have 8, 9 in there already, so I need 6 more. B is 24. I have 10, 16, so I need 8 more. And A is 14, and that makes me sad. In fact, I already have 15 elements in A from my intersections. But I'm then told n of A is 14. That can't be. All right, someone's made a mistake, and thankfully this time it's not me, right? I didn't make this mistake, but my data is bad. I need somebody to fix it before I can make this Venn diagram.